In the last decade, headlines like this are all too common. As science educators, we have all asked ourselves, why is this the case? Is it the students? The teachers? We don't think so. We think it's the tools you've been given to use, and we're convinced that you cannot change your results by using newer versions of standard textbooks. At It's About Time, we do things differently. Our programs are developed with National Science Foundation funding and support, written by scientists and educators, not by in-house authors with little science or teaching experience. Extensively field-tested in schools throughout the country, large and small, urban, suburban, and rural, socioeconomically and racially diverse. We at It's About Time have an extraordinary inquiry-based program to show you, one that we believe can make a difference for you and your students. Active Chemistry is an inquiry-based program. So let's take a moment to define what we mean by inquiry-based. Think about it. Does hands-on equal inquiry? No. Not if students already know how the activity is supposed to turn out. Then it's simply validation, not inquiry. Inquiry is what scientists do. The best way for students to learn, enjoy, and appreciate science is by doing science as student scientists, through inquiry. Science teachers, administrators, and researchers agree that students ought to have the opportunity to learn through inquiry. This includes learning how to ask questions, how to design experiments, how to use evidence to support their claims. Students also must learn the facts, theories, and models of science and how scientists arrived at them. Inquiry cannot be just part of a science program that students experience one day a week for specific content areas, or only when they are in a lab. Inquiry needs to be the way in which they learn science, experience science, and understand science. That's sustained inquiry. Districts using sustained inquiry-based materials report positive gains in many areas. Improved scores on standardized tests. Increased enrollment in upper-level elective science courses. Teachers of upper-level courses report that their students are better prepared for advanced courses. And most importantly, students in classrooms using sustained inquiry programs have a better view of their own science abilities. Active Chemistry is built on the research about how people best learn. What do we know? Learning occurs in context, learning is active, learning is social, and learning is reflective. Active Chemistry applies what we know about how students best learn science in several ways.
The way that the units are set up and that you get to work with other people, and it's actually applied to everyday life. Like everything you do is applied to something that you've done or are going to do in life.
Ooh, purple. Purple. The way the class is set up, you have to think about things a lot more, like try and figure them out for yourself before the teacher just tells you what it is.
Chapters are driven by projects to help students see ties between science and school and the real world, all of which are pertinent to students' everyday lives and all of which involve important science concepts. Throughout the program, students are given the opportunity to do activities where concepts, skills, and content are introduced before there is discussion, direct instruction, or vocabulary introduction. We call this ABC design, that is to say, activity before concept. Students are given a wider variety of ways to be successful and demonstrate knowledge. In addition to traditional tests, quizzes, and homework assignments, students are expected to complete a chapter challenge project, which ties together science, other school subjects, and their everyday lives. This allows for differentiated instruction and helps ESE and ESL students succeed. Most of us are familiar with the 5E learning cycle developed by Roger Bybee of BSCS. Dr. Arthur Eisencraft, author of Active Chemistry, takes this process a step further to the 7E learning cycle by adding elicit and extend. These are important additions. How do we know where to begin teaching if we don't have an understanding of what our students already know? By asking students to extend or use what they have learned in new settings, we give them the opportunity to demonstrate true learning. Now that we've given you some background on our program's philosophy and design, let's open the book. Every chapter starts with a real-world scenario or situation that students have experienced or might experience in their everyday lives. This scenario serves to develop a common ground from which all students will work to introduce the tie between science and their everyday life. The chapter challenge introduces a project that students will be asked to complete. At this point, they do not have all the knowledge or skills necessary to successfully complete the challenge. The chapter challenge is the driving force that keeps students interested. It is the marriage of creativity and the desire to find out. A unique way It's About Time programs deepen student involvement is to include them in determining the criteria for success. The What Do You See and What Do You Think allows teachers a chance to elicit students' prior understandings, as it provides opportunity for students to describe their way of looking at the world and to think about what they already know about the science content. In Investigate, students learn by doing. They are encouraged to work through problems by themselves, in small groups, and as a class. Through this process, they will gain science content knowledge, develop science process skills, learn teamwork, record their findings, and think critically. Within every section, Chem Talk provide deeper and additional content information about the topic addressed in the activity. Completion of the activity prior to reading gives students a reference point, so content is more meaningful. This results in better comprehension and retention of both content and skills. In the reading sections, vocabulary, formulas, and calculations are introduced and explained on an as-needed basis. What do you think now? Ask students to review their thoughts about the elicitation question asked at the beginning of the lesson. This reflection of new knowledge in relation to prior beliefs is essential in eliminating misconceptions. The essential questions ask students to think about how science information they have just learned fits into the big picture and demonstrate molecular as well as symbolic understanding. At the end of each section, students are challenged to reflect on what they have just learned and how it will help them successfully complete the chapter challenge. Chem2Go provides exercises, problems, and questions that ask students to apply what they've just learned to deepen their understanding. This can be used as a class assignment or as homework. Inquiring further provides students with the opportunity to apply newfound knowledge in additional settings. Midway through the chapter, students are given time to begin development of the chapter challenge. Brief presentations are given to share each individual's plans for their project, and students are introduced to the engineering design cycle. This is a dynamic way to emphasize STEM skills, so important for success in the 21st century. At the end of each chapter, there is a review of the content and a review of the sections the students have completed. We also review the criteria for success. This prepares students to be successful in completing the chapter challenge project. And because the knowledge and skills are actually applied, increases student performance on traditional written assessments. The Extend sections connect chemistry to other sciences. The Chemistry at Work pages highlight real-world individuals who use the skills and concepts covered in the unit. Practice tests provide the opportunity for students to review content and apply critical thinking skills prior to formal assessment. If you're not successful, we're not successful. That's why we offer a strong teacher support package, including a full lineup of online teacher resources with enhanced teachers editions, projection masters, assessment generators, and a lesson planner. Teacher support goes beyond background content and answers to the questions. We also provide pedagogical support, which includes concept maps, understanding by design frameworks, pacing guides, equipment lists, and suggestions for differentiated instruction in each section on specific content. In other words, active chemistry is a complete program, with student editions both in print and online, teachers editions in print and online, an exam view test generator, lesson view lesson planner, multimedia DVD, and teacher resource CD. We also offer all of the above, plus the hands-on equipment needed to complete all the activities There are also many opportunities for students to use additional technologies like probeware associated with computerized data collection.
Yesterday you looked at the power sources, didn't you? Those emission tubes, right? Do the kids really understand what's going on with those things? First of all, it's hard enough just to get to see the lines, let alone understand what's going on with the lines, okay? For kids, all they see is colors.
Another essential component of our teacher support package is professional development. We offer everything from half-day introductory workshops to full-fledged 80-hour programs eligible for graduate credit and every conceivable option in between.
So we have to develop methods to work with all students.
Is it possible to change results? Absolutely. How? By selecting science materials that truly engage students, gives them a reason for doing science, programs that are project-based and has students working together in small groups, and programs that embrace the notion of sustained inquiry. One more thing. Be careful of standard programs with new labels. The word inquiry will jump out at you, but if content and vocabulary are presented before investigation, if there is no ongoing provision for students working collaboratively on a chapter project or solving key questions, it's really not inquiry-based material. If the program doesn't start with some sense of students' prior knowledge and use additional knowledge gained by students and supported by evidence throughout the chapter, it's most likely not an inquiry program, just one labeled to get us to think so. Be careful of labels. All of us at It's About Time are convinced that together we can make a real difference for our students. Thanks for listening.